Hey guys, it's Paul Ritzler here, and today I'm going to be showing you guys how to solve a system of equations using elimination. So when you look at this equation, we have, for our first example, negative 9x minus 3y equals negative 9. And then our second equation is 3x minus 3y equals 15. So now when we're eliminating this, we would actually, you can pick any variable that you would want to eliminate. So for this one, say if I wanted to eliminate x, I would raise the 3 to the top, and then I would bring this also over here, except this would be this opposite sign. So instead of negative 9, I would have a positive 9 over here. So now when we multiply these, we have negative 27x, and then so 3 times negative 3 is negative 9, so we would have negative 9y. And then we would also multiply these two, so negative 9 times positive 3 is negative 27. So then down here we would do 9 times 3 is 27x. Then we would do 9 times negative 3y, which is negative 27y. Negative 27y. Okay, so now we do 9 times 15, which is 135. Now, as you can see, these both cancel out, so we're left with solving for y. So negative 9 minus 27 would be negative 36y. Negative 36y. So then now we do negative 27 plus 135. So we have 135 minus 27. So let's solve that. So simple subtraction over here. So we have 1 over here. So now since you can't take 7 away from 5, you would have to borrow from 3, and it becomes a 2, and then this becomes a 15. So 2 minus 2 is 0, and then 15 minus 7 is 8. So we're left with negative 36y equals 108. So now when we look at this, our final step to solve for y is we have to divide both sides of this by negative 36. So we divide both sides by negative 36, and we get y equals negative 3. Because we have a positive 108 divided by a negative 36, so the answer will be a negative number, and 36 times 3 is 108. So we have solved for y. Now, when we're solving for x, we would have to plug the value for y into the equation, into the original equation. So we have 3x minus 3 times negative 3 equals 15. Okay? So we're going to plug it into the second equation over here. So now we have 3x plus 9. 3x plus 9 equals 15. So now our next step to solve for x is we have to subtract 9 from both sides. So we do that, we subtract 9 from both sides, and we get 15 minus 9 over here, which is 6. So then we have 3x equals 6. For our final step, we have 3x equals 6. So now, when we're solving for this, we would divide by 3 on both sides to solve for x. So we're left with x equals 2, because 6 divided by 3 is 2. So we know that our two solutions, or when these two equations also intersect on a graph, the solutions in a ordered pair would be 2x and comma -3y. So this would be our ordered pair. And this is where both of the lines of the equations intersect to get the equals solution. So now, if you want to be sure that this is the correct ordered pair and the correct solution, you would plug both of these numbers into each equation. So as you look back on our example, our first original equation was -9x minus 3y equals -9. So for now, we have to plug in x and y. So to check it, we would do -9 times 2 for x, right? Then we would have -3 minus 3 times -3 equals -9. So equals -9. So now when we check this, we would do -9 times 2, which is -18. And then we would do -3 times -3 is +9, so we add 9 to that. And we simply add these two together. So we have -18 plus +9, which is -9. So that means that it equals the number that we have in our original equation. So that means that that's how you would know that these two are the answers, or the solutions. So now, for our next example, we have both equations, 4x plus 9y equals 7. And then we have 4x plus 3y equals -13. So now for this one, we are going to pick y to eliminate. So for this one, let's put parentheses around both of the equations over here. So now let's carry the 3 over up here, because we're eliminating y to solve for x. And then we would do 9 down here, except it's opposite. So we would do -9. So now we have 3 times 4x, which is 12x. Then we have 3 times 9y, which is 27y. So we have 12x plus 27y. Then we have 3 times 7, which is 21. And then over here, down here, we do -9 times 4x, which is -36x. So then, for this, we also do -9 times -9 times +3y is -27y. Then -9 times 13 is 117. -117. Okay, so now the y's cancel out because we eliminated y, and they're both the opposite signs. So now we take +12x minus 36x, which will give us -24x. And then for over here, we would do 21 minus 17, or -117 plus 21. So for this one, we have 96. We have -96 as our answer. So we have -24x equals -96. So now our final step to solve for x is we have to divide both sides by -24. So divide both sides, and then we will get our answer for x. So we have x equals 4, positive 4, because 24 times 4 is 96. So we have solved for x, and now we can plug it into one of the original equations. Now either one is perfect. It's not any worry about the order that you want to do it or which equation you want to test. You can plug the value of x into any equation that you would like. So let's do the top equation for this example. So we have we plug in x into 4x. So we have 4 times 4, because that's our value of x. X equals 4, plus 9y equals 7. Plus 9y equals 7. So we do 4 times 4, which is 16. 16 plus 9y, which gives equals 7. So now to solve for y, we have to subtract 16 from both sides. So these two cancel out. Subtract 16. So now we have 9y equals negative 9. So now our final step is to divide by 9 on both sides to solve for y. So we are left with y equals negative 1. Now, like I did in my last example, let's plug these values into the equation and let's see if they are the correct ordered pair. So let's do the first equation again. Let's plug 4 in for x and negative 1 in for y. So let's do 4 times 4 over here. 4 times 4 plus 9 times negative 1 equals 7. So now for this one, we would do 4 times 4, which is 16, plus 9 times negative 1, which is negative 9. Then we have 16 plus negative 9, which is positive 7. So that means that if we look back into our original first equation, we got 7. So that means that this ordered pair, 4x and negative 1y, are the correct solutions for this equation. So thank you very much for watching, and I hope you found this video helpful. Bye-bye.